The main important thing I want you guys to understand, again, as we spoke about, quadratic formula is only going to work in this case when we have our quadratic set equal to 0, which in this case we did. But you guys can see there's a lot of those examples, though. You have to move the items around, right? Remember that quadratic is in the form of ax squared plus bx plus c. All right? The first thing I always like to do when I'm doing the quadratic formula is actually, before I even do the discriminant, is I identify what my a is, I identify what my b is, and I identify what my c is. OK? I can't even tell you how many times I see students that make mistakes using the quadratic formula, and they made a wrong input. All right? So I just label it down. It's just automatic. You guys can see my example. That's the first thing I did. It's an automatic. It's something very easy. It's basic. But it just helps me avoid making some mistakes. The second thing I always do is do the discriminant, because the discriminant is the second most popular thing on where students make their mistakes. The discriminant. So in this case, I just plug in what my b is, which is 1 squared minus 4 times a times c. Does everybody follow me? So what I basically have is 1 minus negative 4 times negative 2 is positive 8. Wait, that was 28, right? OK, is positive 8. Positive 8 times negative 28 is 224? Negative 224, or positive 224.
Negative.
Well, yes, it's a negative. You're right. Thank you. So therefore, I have 1 minus 224, which is going to be, wait a minute. That's not 24. 8
times 28 is
224. OK. And then 1 minus that is going to be 223. Is that what we had? Is that what we did?
I got 224, but I don't think this is correct.
No, that's fine. That's fine. I'm not checking that. I'm checking out my 8 times. I'm checking out another problem, or 28, what we did. So what I'm trying to do is I'm trying to determine if 1 minus 220, that's 223. I'm trying to see if 223 has any square numbers I can divide into it. And anybody check any of them? Yeah, I don't think any of them go into. Because basically you have 81, 49.
49 is 77.
Huh? I'm just checking to see if any of the prime numbers go through it. All right, so therefore, I have negative 223. Now, that is going to be, still, even with that number, now we just go through the rest of the quadratic formula. The x values equal opposite of b plus or minus the square root of negative 223. Do you guys see how I just put whatever my discriminant, I just put that under the radical, because that's where the discriminant is. It's under the radical in the quadratic formula. I didn't write in the quadratic formula. X equals opposite of b plus or minus square root of b squared minus 4 times a times c, all over 2 times a. There, then I do 2 times a, which is negative 2. So x equals negative 1 plus or minus the square root of negative 223 divided by negative 4. We could easily divide that negative 4 into both of those. Also, I want you guys to understand that actually, I'm going to want to explain this the other way. But understand that when you're taking the square root, you cannot take the square root of a negative number in the real number system. However, today we're going to talk about the complex number system, where that would be 223i. Don't worry about it. I'm going to re-explain that later. But I would write my final answer as x equals positive 1/4 plus or minus 1/4 I times the square root of 223. I will go over all of that again later. Yes? You could, but a lot of times, especially like today, where I'm going to be talking about the zeros and stuff, you're going to want to break them apart as zeros like this. You're not going to want to leave your zeros as rational. So it all just kind of depends on what type of problem, what you're doing. Yes?
Since the I count is a negative 1, why can't you remove the negative, but you can use the negative 1?
Because what?
Like, you know how I count is negative 1, right? Why can't you pull that out and pull out the negative 1? Or does it still count?
Yeah, it's only the square root of negative 1. That would be I guess, basically the difference. All right.